Welcome to this explainer. Today, we're going to uncover the shocking mathematical truth hiding right inside the beautiful melodies of your absolute favorite songs. Have you ever wondered why certain combinations of notes give you goosebumps while others make you want to cover your ears? Well, the answer isn't just art. It's cold, hard, beautiful math. Okay, let's dive into this. Think about the famous rising octave that opens so many 20th century classics. You know the ones. Think of the iconic first two notes of Somewhere Over the Rainbow, or the joyous opening of Singin' in the Rain. When you hear that sweeping, uplifting leap from the first note to the second, what are you actually experiencing? It feels like pure, unadulterated emotion, right? Well, guess what? It turns out that this beautiful, emotional musical leap is literally just a simple mathematical frequency ratio of 2 to 1. That's it. That soaring feeling in your chest is just your brain successfully processing the fact that the second note is vibrating exactly twice as fast as the first. This simple frequency relationship is the entire basis for the construction of any musical scale. But how on earth did humanity figure that out? Section 1. Pythagoras in the Forge, the Legend of Harmony. Let's step back in time. Legend has it that around 550 BC, the great Greek philosopher and mathematician Pythagoras was walking past a blacksmith's forge. And suddenly, he noticed something incredible about the ringing sounds of the blacksmith's hammers hitting the anvils. This legend, which was later passed down to us by the Roman writer Boethius, claims Pythagoras realized that the harmonious sounds of the blacksmith's hammers extraordinarily corresponded to their physical masses. He supposedly discovered that the hammers producing consonant, pleasing sounds had physical weights that formed simple, whole-number mathematical ratios to one another. Our ancestors were absolutely obsessed with the geometry of sound. You'll often see historical depictions filled with intricate numbers and architectural grids surrounding this forge scene. It just goes to show that, regardless of whether the blacksmith story is a colorful myth or literal history, it sparked a very hard mathematical truth. Consonant sounds and simple number ratios share the exact same fundamental basis. Music and math were suddenly locked together. Section 2. Music as a Science. From the Quadrivium to Oxford. Look at the sheer span of time we're talking about here. We start with Pythagoras' ancient insights around 550 BC, travel through the Roman era where Boethius cast a massive shadow over the next 1,000 years of thought, all the way to the monumental founding of a chair in music at Oxford University in 1627. This wasn't just a fleeting trend. This was the dominant way human beings understood sound for millennia. In fact, for centuries under that influential tradition of Boethius, music wasn't just treated as an expressive art. It was grouped strictly into what was called the Quadrivium. Music was aligned directly with arithmetic, astronomy, and geometry as a core analytical science. So while grammar and logic formed the language arts, music was considered a fundamental property of the physical and mathematical universe. Things got really interesting when music was formally divided. Back in 1597, Thomas Morley perfectly broke it down into two distinct camps. On one side, you have speculative music. This is the mathematical side that seeks out the causes and properties of sounds using math. On the other side, there's practical music, the art of actually teaching songs and composing. Both were completely valid, but the speculative side, that was pure science. This dual nature was institutionalized by figures like William Heather, who founded the chair in music at Oxford in 1627, explicitly providing for both the practice of music and lectures on its science. Centuries later, in 1831, Professor William Crotch held that exact same chair and powerfully championed the idea that music is absolutely both an art and a science. Professor Crotch actually used an incredible quote from Sir William Jones to make his point. He said, "Music belongs as a science to an interesting part of natural philosophy, which, by mathematical deductions, explains the causes and properties of sound, but, considered as an art, it combines the sounds to captivate the fancy." I mean, wow, that perfectly summarizes it, right? Music uses mathematical deductions to explain reality, while simultaneously captivating our artistic imaginations. Section 3. The Scientific Revolution. Pitch and Frequency. This deep academic foundation leads us straight into the 17th century scientific revolution, a time when the greatest scientific minds on the planet turned their highly focused attention to music. The conceptual problems involving the division of musical space were a massive challenge. Thinkers like Descartes, Oughtred, and Wallace tackled the musical scale. Then, in the 1660s, none other than Isaac Newton learned everything they had developed and rapidly pushed beyond them. This era led to a monumental discovery. the realization that musical pitch is definitively identified with measurable frequency. Combined with figures like Mersenne establishing the laws of modern acoustics, music was proving that the universe is quite literally constructed on mathematical laws. Section 4. The Architecture of Harmony, Breaking Down the Ratios. So how do these ancient discoveries and scientific breakthroughs actually build the musical scales that we stream on our phones today? Well, it all comes back to the oldest system of scale construction, known as the Pythagorean scale. The mathematical strategy here is breathtakingly simple, yet infinitely complex in its application. You simply take a single starting bass note, and you produce the other notes by multiplying its frequency by simple fractions. It is literally just fractions. If our bass note is the variable t, operating at a 1-to-1 ratio, we can build the rest of the scale right from there. A perfect fifth is a 3-to-2 ratio, and that soaring emotional octave we talked about earlier from Somewhere Over the Rainbow, that lands perfectly on the mathematical value of 2t, a 2-to-1 ratio. The human ear just instinctively loves the elegance and simplicity of these fractions. Which brings us to the end of our journey today, leaving us with a final fascinating thought to take away. If the very art that moves our souls, the music that makes us cry, makes us dance, and makes us feel alive, is simply an expression of universal math and simple fractions, what other beautiful hidden equations are shaping your daily life right now, completely out of sight? The world really is built on math, and as Pythagoras discovered in that forge all those years ago, it sounds like a masterpiece.